Hello, calculus students. This is Math 181, 5.3, the Fundamental Theorem of Calculus, Part 2, Evaluating Definite Integrals. Before we get to that, I am going to work these problems. Oh, okay, I was thrown off a little bit. The indefinite integral is if f is a continuous function, then the integral of f of x is equal to the antiderivative, where capital F of x is the antiderivative of f. Okay, there we go. So we're going to do these practice problems, and I started over here. Number 1, the integral of 6x squared plus 4x plus 5 and dx. So what I'm going to do is my power rule. So I add 1 to that, so I get x to the third over 3 plus 4x squared over 2 plus 5x, and then plus c. So I will simplify that. That's 2x cubed plus 2x squared plus 5x plus c. And there you have it. That is the antiderivative. And notice that the integral and the dx go away as soon as you start using the rules, like the power rule here. And now this one, I'm going to have to put the integral because I first have to write this as a power of 4/5, like that. So we got the power of 4/5, and we're going to add 1 to that. So that's going to be 9/5 over 9/5 plus c, giving 5/9 x to the 9/5 plus c. There you go. And notice I have the integral here because I haven't done any rule yet. Now I'm doing a power rule. And then you wouldn't leave it with a 9/5 in the denominator. You just multiply by the reciprocal. This one's the integral, number 3, of 2x minus e to the x. We can just do that. 2x squared over 2 minus the integral of e to the x is e to the x plus c, which gives x squared minus e to the x plus c. Number 4. Now this one, we're going to have to multiply it out. So this will be u to the 4th plus 2u squared plus 1. If you need to, you'll just go u squared plus 1 times u squared plus 1, and you'll see that you get u to the 4th plus 2u squared plus 1 du. And I don't take away the integral yet. I'm getting ready to now, because that was just a rewrite. So this is a rewrite of this. This up here was also a rewrite before we integrated. So when you just do a rewrite, you still keep your integral. Now I'm going to integrate. So this becomes u to the 5th over 5 plus 2u to the 3rd over 3 plus u plus c. And that's it. Nothing to simplify even. Next, this one is the integral of x to the negative 1. I'm doing a rewrite. Not even integrating. I'm rewriting that so that it has a power. Plus x to the negative 2nd power dx. And now I'm going to integrate, so the integral goes away, and I get, that's going to be ln, absolute value of x, plus x to the negative 1 over negative 1 plus c. And I would just write that as the ln absolute value of x minus probably 1 over x plus c. All right, that is 1 through 5. Number 6 on this worksheet is the integral of secant squared, and that is tangent x plus c, because the it's t, excuse me, wrong variable. The derivative of tangent t is secant squared t, and no more integral. I'm done. That's it. This one's going to be 6. This is tangent inverse of x plus c. Okay. This one you just have to recognize as one of the inverse trig functions, because nothing else is going to, you can't rewrite that, because you'd have to take the entire, you can't just flip things up into the numerator. You would have to flip this entire thing, which would be to the negative 1. It's just a very unusual looking one, so that takes you into those inverse trig functions. This one can be rewritten. This is the integral of 1 over cosine squared x plus cosine squared x over cosine squared x. And notice This is just a rewrite, so I don't have to take away the integral, and you don't. It would be incorrect if you did. And I'm going to still rewrite. When I rewrite that, 1 over the cosine squared is secant squared x, and that's just plus 1 dx. And now I can separate these and integrate, because the integral of secant squared, well, it was up here, is tangent. I'll write it down here. So I get the tangent of x, that's for this one, plus, and no more integral, plus x, because the integral of 1 is x, plus c. Last one, this is going to be a definite integral, so I'll be back with number 9.